Hello everyone, I'm Paul Lefevre, the Xojo Developer Evangelist, and welcome to this week's Xojo webinar. This week's topic is a continuation of our Introduction to Programming topic that we did a few weeks ago. And this week we're essentially just going to wrap up a few of the topics that we didn't get to last time. Looking at my list here, it looks like I want to cover Boolean expressions, data collections, and methods, and maybe a few other things mixed in here or there. I want to encourage everyone to feel free to ask questions as I'm talking. They pop up on my other screen. I'll look at them when appropriate and I can get to them. So don't hesitate to type in your questions into the questions window. Love getting questions. So let's get started by just opening up Xojo here with a little intro project that we can type some code into. Now, much like last time, we're going to be looking just at some very simple code, so we don't need anything too advanced. So I'm just going to add a button here and add its action event handler just to give me a place to type in some code and an easy way for me to run the code. I'll be able to run the project, click the button to run any code that we happen to type in here that we want to see on the screen. Now to start with, I want to talk a bit about Boolean expressions. I believe I may have touched on this a little bit last time, but there's a few other things I want to bring up. So a Boolean expression is anything that can evaluate to true or false. So for example, if I declare an integer right here and I set its value to 2, I can use in an if statement a Boolean expression to say, for example, check the value of that integer. So I could say if I equals 10, then, and I could display a message that says something like value is 10. This right here is the Boolean expression, the I equals 10 part. Now in this particular case, this expression evaluates to false because I most definitely is not equal to 10. It is actually equal to 2. So this message box would not appear because this expression evaluates to false, so the then does not get evaluated. However, if it evaluated to true, which it would, for example, if I set it like this, since I is 2, this would evaluate to 2, so the message box would be displayed on the screen when this program runs. Now you can use other commands as well. I could use the less than symbol here to say, all right, if I is less than 10, I don't care specifically what it is, but if it's less than 10, that's my Boolean expression. And in this case, I being 2 is obviously less than 10. So you can do stuff like that. You can do not equal to, so you could say, is it not equal to a value? And you can, of course, also do greater than equal, less than equal, that sort of thing. And you can combine them as well. So you could do if I is greater than 1 and I is less than 10. Now this has two Boolean expressions here. You have the first one here, I greater than 1, which evaluates to true because I equals 2. And you have the second expression, I less than 10, which also evaluates to true because I equals 2. And they're combined using the AND operator here in the middle. And the AND operator says that both sides of both of the expressions have to evaluate to true in order for the entire expression, which is the combination of all of this, to evaluate to true. Now in this particular case, first part evaluates to true, the second part evaluates to true. So combining them together using AND also evaluates to true, so the message box would be displayed. If one part happened to evaluate to false, so if we had written it like this, I greater than 5 would evaluate to false because I is 2. So we would end up with this part of the expression being false, this part of the expression being true, and the AND operator would then, as a whole, be evaluated to false, and the message box would not appear. You can also use the OR operator, which compares the two, but only one of the two, or both, have to evaluate to true in order for the entire expression to be equal to true. So those are very commonly used operators that are used to combine Boolean expressions to get a certain result that you may be looking for. The other one, and I don't want to, we're going to put a couple other pieces of code in here. I'm going to just use some simple Boolean variables. So I just have 3 simple Boolean variables here, and I will set them to the weather as I look out my window. I will set this to false here. And then looking at the trees, I do not see any wind, so we'll set this to false, but it is cloudy out. So I now have these 3 Boolean values that are set up. They continue to work just like when we were using an integer, except a Boolean variable is its own Boolean expression. But one command I wanted to point out is the not command, which flips the value of a Boolean expression. So I can say something like here, if not sunny, and maybe you can put something like that, bring an umbrella. So here it's checking if not sunny. Well, what does that mean? That means pretty much it means exactly if you wrote if sunny equals false. Now, sometimes this is a more convenient or sometimes a more readable way to write code, particularly if your variables happen to be written in a way that makes it seem like a sentence. But this is a common way to flip the contents of whatever the Boolean expression may be. And it kind of goes along with the and the or operators that I mentioned earlier. So I just wanted to point that out there. And you can use it, I could use it like here, if sunny equals false, I could say, well, if it's not sunny, then cloudy equals true. And you can start to, use that to set up your program to have certain expectations. All right, I'm just checking over my list here. That appears to cover everything I wanted to mention about Boolean expressions. So we're going to move on to our next topic, which is collections of data. Now, primarily, we've been creating variables that just store one thing at a time, a number, piece of text, something like that. Well, oftentimes in your programs, you're going to need to have a way to store a collection of data, typically a list of something. And there are a variety of ways to do that sort of thing. So we're going to look at a few of them here. The most common one is something called an array. An array is essentially, like I said before, a list of data. You can declare an array like this. And you'll notice the big difference in the syntax is the parentheses here with the number that is in the middle. And this is essentially saying that it's creating an array that has indexes up to the number 10. And it can contain only integers. Now, in the case of Xojo, the important thing to remember is that even though I've put a 10 here, this doesn't mean there are 10 spots in this array. It actually means there are 11, because Xojo arrays are indexed starting at 0. So this means here that I have a value at my array 0 that I can set to something, a number, and I can do this all the way up to, I'm not going to go through all of them, but I can do it all the way up to the last one, which is 10. And counting from 0 to 10 would actually give you 11 entries. So there's always one extra entry when you declare an item like this higher than the number you're actually looking at. So that's an important thing to remember, because that can be a little confusing at times. And the list is handy because it allows you to store a bunch of different values in what appears to be a single variable that you've declared. And then you can start to do things with them. So let's go through. Let's make this a little smaller so it's easier to type. So one thing you can do with an array is you can pre-populate it with information. So here I've created my array, and I've pre-populated it with some numbers. And I could add these numbers up by going through the array and adding each item one at a time. And I could do that manually by typing it like this. But this gets pretty tedious very quickly. And often when you're dealing with arrays, you don't always know exactly how many entries you may have in your list of items that are in the array. So you often end up using one of the commands that discussed last time, which is a loop. And a for loop is a common type of loop that works great with arrays. So here I am saying I want to go through each item in the array. So for each item that's in the array, and I'm going to declare a variable here that I'll just call n, and it has to match the type of the array and use the right syntax. I will get n each time through the loop will be equal to each value that you see in the array. So 1, 2, 3, 4. So I can write code that adds that up. And then each time through the loop, the sum will be increased by the next value that it fetches from the array. Now here I made these go in increasing order, but they obviously can be anything, and it will calculate the sum of whatever happens to be in the array. Another way you can declare an array, as I mentioned earlier that you often don't know how many elements you're going to have in an array, is you can declare it without a number in there. So here I've just put the opening and closing parentheses, but I didn't include a number in it. This means that this variable is an array, but it starts off empty. It has nothing in it. So you cannot access it directly. If I try to reference something in it, any number, I'm going to get an error when I run my program because that index is not yet in the array. The array starts out empty. So to start with, you actually need to put something in the array. Now you can still put stuff in it using the array keyword like I just used, and it'll populate the array with however many values you specify in the keyword. The other thing you can do is you can use the append method of an array to start adding values to the array. So this adds the value 45 to the first entry in the array because the array is empty, so that would be index 0. And if I call this again and append another value, it would add it to the end of the array. And since this adds index 0 to the array, this one would add the next available index, which would be index 1. So after doing this, I would be able to refer to the array 0. And I could, combine it with Boolean expressions so I could check its value. This would be false because we put 45 in array 0. So this is how you add stuff. And as we tend to say, this is dynamically because you're doing it as the program is running. And it's very handy because when you build a user interface and you let your user type in information, you're not often going to know what they're going to type in. If you're dealing with a spreadsheet or something like that and they're typing in a whole series of numbers, you can't just tell them necessarily, all right, you've only going to enter 10 numbers and you have to enter exactly 10. That's not very user friendly. So array is defined as this, that you adjust to whatever input information you've received, whether it's a user typing data or a file that you've gotten from somewhere or whatnot, allows you to just populate your array with the actual data that you've been given. Now, one thing about arrays is they can get a little slow if they have lots and lots of items in them. Because you have to search, if you're searching for a specific value. So say you had an array here, but it wasn't integers, it was strings. And you had the strings be something like names. Well, if you had thousands of these names in your array, and you were attempting to looking for a specific one, you would have to loop through the array and check each one at a time, which could get pretty slow if you're doing that sort of thing repeatedly. So arrays can become a bit of a performance problem depending on how your application is designed. So that is something to keep in mind for how they're being used. And that'll kind of segue into our next data structure, which is the dictionary, which is a much more powerful data structure, and we'll look at in just a second. As the one other type of array I wanted to point out is you can have what is called a multidimensional array by including two values here in your declaration. And you can think of this as, rather than a list, kind of like a grid, almost like a spreadsheet, if you will. So this has, remember, everything starts at 0, so this has 0 to 5, which is 6 values across and 6 values down. So you get this grid that you can access using the coordinates that you specify here. Not as commonly used, but again, it depends on the type of application that you are building and how you need to store your data internally. All right, so let's move on now to dictionary. Now, unlike a lot of the stuff we've been looking at so far, dictionary is actually a class that's included in the Xojo framework. Now, classes are something that I'll be talking about in much greater detail in the object-oriented programming webinars in June and July. But this is a pretty important class for data storage and whatnot, so I think it makes sense to talk about here. So a class is essentially something that is used to store information. Now, in the case of a dictionary, you declare one like this. So you have to give it a variable name, of course, but this new keyword is used to create what is called a new instance of something that is a class. So this essentially gives us a reference to it that we can now use in our programs. If we left this off and just tried to type dimd as dictionary, kind of like what we did with string and integer and that sort of thing, we would get a runtime error when we tried to use D because it hasn't actually been initialized. So you can think of the new keyword as doing an initialization of sorts. But once you have initialized your dictionary in this manner, you can use it to store all kinds of information. The cool thing about the dictionary is it doesn't really care what you put in it. And it doesn't care how you look up what's in it. You'll remember that the arrays used an index and used an integer index, always starting at 0. Well, with a dictionary, you call the value method, and you pass in whatever you want to be the value you want to look up or store your data by. So it can be an integer. I could put here, value. I want the value of 1 to be equal to a string, for example. But I don't have to use an integer here. I could use an actual piece of text. And I could type, and I could assign it whatever I wanted. So another string, or I could assign it a number. It doesn't matter, and you don't have to predefine any of that. And you can just continue to add things in that manner. And you can, of course, put any number of things that you want in a dictionary. And one cool thing about dictionary is it's very, very speedy. It uses some behind-the-scenes things, in particular something called what's called a hash table, to organize the data into buckets, if you will, so that it's much faster to look stuff up. So rather than having to iterate through a gigantic list like you would do with an array, it's almost as if the list is broken into little smaller lists that you can more quickly use to find things. So dictionaries are an incredibly powerful data storage that's included with Xojo that you definitely want to take advantage of. And they're particularly useful with other classes, and I'm sure they'll be covered again as well in the object-oriented programming webinars. But I do want to point them out now just because they can be incredibly handy and you do want to be aware of them. If you're coming from another language such as Visual Basic, you may have seen there a data storage type called collections or collection. And Xojo does include a collection data type, but it's mostly for backwards compatibility with stuff like Visual Basic. And in nearly every case, you're going to just want to use a dictionary instead of a collection. Dictionaries are faster, more flexible with the type of keys you can use here to put your values in, and overall are the more appropriate data storage type to use. All right, I'm just checking my list here, and it looks like it is poll time. So let me just switch over to my poll selector, and I'm going to go through, I think I have about four polls here that I'm just going to run real quick. And for people watching the recording, you won't be able to see the polls. People attending live can see the polls and can vote in them, which is great for us, helps to give us more information about type of folks that are using Xojo. So our first poll question here is, what type of apps do you primarily create with Xojo? Now, of course, I know this is kind of an introduction webinar, and perhaps many of you aren't yet even creating any apps, but feel free to answer the question as best you can. And if you can't, or you don't have an answer, then don't feel that you have to make one up. Obviously, at this point, the two choices are, do you create desktop apps or do you create web apps? And we're very excited to be adding iOS apps to that in the future later this year. All right, let me move on to the next poll here. All right, this poll is asking if you have a Xojo Pro license. As you may be aware, Xojo is available with a few different types of licenses, desktop, web, console. And the Xojo Pro license essentially gives you every license that you can get with Xojo in a single license that allows you to create desktop apps, web apps, database, connect to all kinds of databases, consoles, that sort of thing. All right, let's move on to our next poll. And this poll is, how long have you been using Xojo? I probably don't expect anyone to be choosing the 10 plus years option if you're attending the introduction webinar, but maybe. And our last poll here is, how do you use Xojo? And there's a variety of things here. You can select more than one. And as I might expect on an introduction webinar like this, I do see that about a majority of people are checking the option that says I'm learning how to program, which is great. All right, so that's the last poll. So let me close that one, and we can move on to our next topic, which is methods. Now, all the code that I've been writing here, I've just been typing here into this action event handler of a push button. Now, methods are, well, I can say that events are essentially a specialized version of a method. So right now, I'm going to create a method. Let's get rid of this code here. I'm going to click the little plus button on the toolbar. And you can see right here, there's lots of options. We're not going to get into all of those because we're primarily at the moment concerned with places where we can put the code that we are writing. And a method is such a place. Now, methods can exist in pretty much anything that you can add over here to your project. Right now, we're adding the method to our default window. We could also have added a method to this app class that appears here by default in all your projects. And I'll talk a little bit more later about modules, which is also a common place to put methods. And then, of course, when you're doing object-oriented programming, primarily your methods are going to be in classes. So you can see here when I added the method, I got a code editor just like I saw with the action event. But on the right, I got a few properties. Now, the first one is most obviously the method name. Methods need a name. Everything needs a name when you're programming. And, variables need names. Methods need names. Method names have the same rules that variable names had that I talked about in the last intro to programming webinar. Has to start with a ASCII character of some kind. I should say an ASCII letter of some kind. And let's see, we'll call this show name. So I've given my method here something called show name. Now it's good to have some sort of idea about how you want to name your methods and not just give them kind of random willy-nilly names. So people often like to give methods a name that describes what it is that the method's actually doing, or perhaps if the method is returning some result back, describes what the result is that's being returned. So in this particular case, we're just going to have our method show a name. So show name seems like an appropriate name for our method. The next thing to look at in the method inspector here is parameters. Now you can pass in values to a method, and this is what the real power of methods starts to become, because it allows you to create code that you can reuse and can do different things depending on the information you supply to it. So you can list here variables that will be provided information when you call the method, and then these variables can be used in the method code. We'll look at some examples here in a moment, but that's where you would type all this stuff. The next thing is the return type, which is optional, as are the parameters. And the return type essentially converts a method into a function, which means it'll return a result of some kind. So the method will run, and then you'll pass back a value to whoever called the method. And the last thing is you can control the scope of a method. And you can see here there are three options for the scope: public, protected, and private. And scope essentially means visibility. Who can see this method? A method that is public can be seen by anybody. So a different window could see this method. If this were in a class, different classes could see the method. So that's the most global type of method, and probably the one you want to use the least often. But that's the first one that's on the list. The next one is protected, and this makes more sense in conjunction with object-oriented programming and classes. So I'm going to skip over that one. And then the next one is private, which, as you see, if I pick this here, you can see there's a little indicator in the navigator that's, in this case, put a red dot next to it. Depending on your Xojo preferences, it may have made the whole thing be red. But essentially, something that is marked as private means that this is only visible to the object that contains it. So in this particular case, if we have our showName method as private, then the only thing that can see it is the window that is holding it, in this case, window 1. It won't be accessible to other windows or other classes or anything like that. Having things be private increases the safety of your code, because it prevents your code from, it mostly prevents you from calling code that perhaps you shouldn't have been calling, and then creating unnecessary dependencies throughout your project that could be making it more complicated or introduce bugs and that sort of thing. So when I'm writing my methods, I almost always set them to private first, and then I will reduce their scope, going to protected or public, if I deem that necessary. And going in that manner allows me to think about it a little more, so I don't just blindly start using things without thinking about the consequences. So our little show name method here we can start off with won't be very sophisticated. We'll continue to use the message box command here, and we can have it just just display my name in the message box. So let's call our method. And you call a method just by typing its name. Now I didn't specify any parameters, so I can just call it by typing its name. And when I run the project here, I'm going to click the button which runs the action event. The action event code calls our method, which is displaying the name. Not terribly exciting, I know. But we can tweak this a little bit here by adding a parameter. And instead of always displaying Paul, we can display whatever happened to be passed in as the parameter. And we're able to use that parameter just as if it were any other variable. So I can just type it right here. Now, since this is now expecting a parameter, you can see, as I put the cursor over it, down here at the bottom, it now shows you the signature, and it says that it takes a name, and it has to be a string. So I could pass it that parameter, and I could pass it Paul right here, and we get the same result. But it's starting to get a little bit more modular, as I can change this more easily and start to get different results. But it's still tied to whatever I enter for code. So then I could say, all right, well, let's make this just a slightly more clever, and we'll add a text field and let the user type whatever they want in here. But we'll display what they type in here. So we'll get the text field, we'll get whatever text was typed into the text field, and we'll pass it to our showName method to display. Now our method is even more flexible because whatever I type in here now appears. All right, let me just scan a couple questions I got here. All right, jumping back to our prior topic, I should have checked the question a little earlier, I guess. John has a question about dictionary and is asking if the value part of the dictionary had to be unique. So that's the where I used the I had a dictionary, then I set its value to Paul, and then I set that equal to my last name, Lefevre. And yes, the key of a dictionary does have to be unique. Otherwise, you wouldn't be able to look up things. So if you set different data for the same key, it overwrites what the other thing was pointing towards. And Mike is asking if there's an example of what dictionaries can be used for. And specifically, dictionaries can be used for pretty much anything. Specifically, I commonly use them for maintaining application preferences, for example. I may want to store in a bunch of settings for, maybe font sizes, colors of things, default user, default email. You can put all that in a dictionary that everything in your project can access, and then you have easy reference to all these things that you can look up by their names. But, I mean, really, a dictionary can be used to store anything. You can use them to store information you get back from a database that you can then write back to the database. The sky's the limit with a dictionary. It's very, very flexible data type. All right, that brief digression. Let me go back to a couple other methods to create here. So that's our simple show name one. Now let's create another method here. And we'll start to create some methods that do really simple things, but just to demonstrate some stuff. This one will have two parameters, but one of them I've assigned a default value. I've made the first parameter is an integer, and the second one is also an integer, but I've assigned it a default value of 1. And what should our code do here? Well, if we're adding these things, actually I want to also return an integer. So this now becomes a function. So it's going to add these two values together and return the result. So we can do this in one line here by doing return x plus y. Very exciting. But let's see how we would call something like that. Well, since it's returning a value, we're going to want a variable to store that value. And then we can call it using its name. And I can put the cursor over here so you can see the syntax again if you've forgotten it. And you can see it takes two integers, but the second one has a default value of 1. That means it's optional. So it means I don't actually have to include it. So if I just pass in one value, it will work. X will get the value of 10. Y, because it wasn't specifically supplied, will get its default value of 1. So our result ought to be 10 plus 1, or 11, which we'll just quickly display in a message box here. And of course, we could supply the second value if we wanted, and then get our result. So that's how an add method could work that's specifying a return value. And there are multiple parameters here. Now, there's one other thing I want to point out, and that is having how the parameters are passed in. So let's go back here and now we don't have to pass these things in by typing specific numbers. These, of course, can be variables themselves. And you get the same result when you run this. But what happens when these two variables are passed in? They're passed into the method here, and they're put into the parameters. Now, I'm not really doing anything with the parameters here, but what if I was? What if I was first taking the value of x and doubling it? And then I was adding them together. Well, I would get a result of, I forget what the first one is, so 10 times 2 is 20, plus that is 35. Now the question is, does manipulating this value here that was passed in affect the value 1 that was way back here in the calling method? And the answer is normally no. And that's because when you're passing in things like this, they're passed in by value. So only the value is getting passed in, not the actual variable itself. So it's essentially a copy. So manipulating that copy in here does not affect the original out here. So if I instead change this to say display value 1, it's still going to show this as 10, even though in our method we doubled it. Now that's really good, but sometimes you may want to actually have the value that's manipulated in here be accessible back to the caller. And you can do that. And you do that by specifying your parameter with an additional keyword called byref. And that means rather than passing the parameter by value, you're passing a reference to it. And a reference essentially means that rather than making a copy, it's using the same one that it started with. So in this particular case, since we're passing in the same one that we started with, we go back to our code here, we should expect value 1, because it was modified and doubled, to show here as 20. Which it does. Now, why would you want to do this? Well, in certain cases, you may come up with a method that you actually need to get multiple return values back from. And you can only return one value from here in the return type. So if you have additional information you want to return, could be an error code, could just be that there's multiple pieces of information that you need to return. Using by ref can be a way to do that. That's not a common occurrence, but this is the technique that you would use to go about that. All right, I am just checking my list here. All right, so methods are essentially the containers of code, if you will. And you're writing code, it's going to be in a method of some kind. I mentioned earlier that this is an event. An event is essentially a specialized form of a method, which is exactly what it is. By default, all the Xojo user interface controls have a wide variety of events on them that you can implement and then put your code in. Here we're looking at a push button. And you can see all the various event handlers that are available for a push button. And you can just pick any of these. And then you'll get a new event handler where you can type your code. And it's just a specialized method that is called in a certain situation automatically for you. In the case of the push button, for example, the action event handler is automatically called for you when the user presses the button, clicks on the button. The open event handler would be automatically called for you when the button is actually drawn on the window, that sort of thing. So that gives you your event-driven processing that allows your application to interact with, or allows your code to interact with however the user is using your application. Another place you can put that you can put methods is on modules. I'm going to add a module here to the project. And you can think of a module as essentially a global container of things. So right now, this module is just sitting here, doesn't do or have anything in it. But I can add a method to it. And I now have a method that's in my module. I can give it a name. And has the same thing, a name, parameters, return type. There's also a scope. The scope is slightly different when dealing with a module. There is global, which essentially means that you can refer to this method name anywhere in your project without prefixing it with anything. So just by typing display name anywhere else in the code of my project, we'll call this method. Having that level of global methods is not always the best idea because you may forget exactly where they're declared. So generally I try to stay away from that. The next level in a module is protected. And that tells the method that it can be called from anywhere in your code, but you have to prefix it with the module name. So here you can click on the module and give it a useful name. And maybe it's not a useful name, but you can call it at least something to remind you of where the declaration is. And then, I'll put it right here. To call that particular method, you would start with the module name and then put a dot and then type the method name. And since that's the only method that's on that module, it kind of pre-filled it in for me. But this is how you would call that method if it's marked as protected. This is the preferred way to call methods that are sitting on a module because it makes it very clear where they're coming from. It's in the utilities module and you're calling the display name method. And of course, the last option is private, which essentially just means that the method can only be called within the module itself because the module is its container. And that's handy for methods that are support methods that are called by, a different method that's on the module. Going back to method parameter definitions, Mike is asking if you can also use by val in place of by ref. So if we go back to our method here, recall I used by ref here to indicate this was by reference, and y doesn't have any prefix. I could certainly type by val here. That's the default if you don't include it. Hardly anyone ever types by val, so that might look a little odd to people if you do start typing it, but it certainly would be allowed. So modules can be a great place to put code, and certainly if you have code that needs to be used in more than one place, it makes sense to put it someplace that is more easily reusable. So if you had a add method that you were using and you had it on and you needed to use it on multiple windows, well, it would not make sense to just copy your add method to all the windows and have the exact same code everywhere duplicated. It would make more sense to put that particular method on a module that you can then call from all your windows. Having a single point of source code gives you only one place that you need to have to change should you need to update any of the code, and it's just a better, cleaner design. And of course, other things that I haven't specifically gotten into that kind of are companions to methods are properties and constants. And they're just available here right alongside the ability to add methods. You can add properties and you can add a constant. And a property you can think of as essentially a variable that is accessible to the entire containing object. So I could add property here and, declare it much like you would when you were writing code using the dim statement. And the scoping rules have the same, work the same way. But by declaring it here, I could refer to it inside of code in multiple methods. So it can be very handy if you have something that is manipulating a piece of information and multiple methods need to access it. You can make it a property, and then all the methods have it available to them. A constant works the same way, except that it's just a constant value that multiple things may need access to. Next month, the continuation of this series will be the first part of the object-oriented programming webinar, which will cover classes essentially, and that really is the key to building good applications using any modern programming language such as Xojo, is to take advantage of classes and their object-oriented capabilities. So that'll be a good session for people that have watched these to move into, so you can see how you may start to design applications in that manner. And of course, remember that you're always using object-oriented capabilities, even if you're not designing your own classes, just by the fact of dragging controls onto windows. Every one of these controls is a class. Dragging it onto the window creates an instance of that class that you're then using and the user is interacting with. So even though you may not be at the level where you're designing your own classes and reusing things in that manner, you are taking advantage of the built-in object-oriented capabilities of Xojo just when you're designing your user interface layouts. All right, well, that gets me through my entire agenda for this webinar. So certainly, I imagine you've all done so by now, but if you haven't, do grab your free download of Xojo and play around. There's no cost to download Xojo and use it to learn and write your own apps that run directly from Xojo. So by all means, take advantage of that. I want to point out upcoming webinars. Next week is the Good Guy Listbox webinar. which covers some specific ways that you can use list box control, and perhaps these are ways that you may never have thought of before. And then after that are a couple more sessions that are great for beginners, design patterns and introduction to object-oriented programming. If you haven't already, our YouTube channel you can subscribe to if you have a YouTube account, let you know when new videos are posted up here, usually a day or so after the webinar. And I have recently created a Getting Started playlist that will have this webinar in it as well, but has most of the webinars that are geared towards people just starting out with either Xojo or programming in general. And of course, you can head on over to the wiki videos section as well, which has a very lengthy reverse chronological list of all the webinars and links to example projects for webinars that do have example projects, so you can grab them, download, play around with the code and whatnot. And if you do use an RSS reader, you can also come here to get the link to subscribe to the RSS feed for the YouTube channel, so you'll also get notification that way when new videos appear. So I think that wraps it up for this week. I want to thank everyone for attending, and have a great rest of your day.